Let's have a look at calculating the equilibrium constant if we know the values of our things in our system at equilibrium. For the following hypothetical equilibrium, A plus 2B forms 2C and D, what is the value of the equilibrium concentration if these are the concentrations at equilibrium? So first of all, first step in any calculation is to try and write down what your equilibrium expression will be. Now it's going to be the reactants, so the products over reactants to the power of their coefficients. So it's concentration of C to the power of 2 times concentration of D. That's going to be divided by concentration of A times concentration of B squared. Okay, so that's my equilibrium expression. Now, it doesn't have a unit because all these guys cancel out. I'll talk about units another day, but for now, let's just look at substituting these values in. Our C value was 9.4 times 10 to the power of negative 3. That will be squared times by 1.2 times 10 to the power of negative 2. That's all divided by our concentration of A, which is 4.5 times 10 to the power of negative 5. And that's going to be times by 2.2 times 10 to the power of negative 2, and that's going to be squared because we've got 2 in front of there. So this is going to be our equilibrium expression. This is going to be relatively hard to do on a scientific calculator, so I might break it down into 2 parts. So what I'll do first of all is I'll do this one here. So bracket 9.4 times 10 to the power of, where's my power? Negative 3, bracket to the power of 2. So I'll work out what that value is, and it's this one here. So it's going to be 8.836 times 10 to the power of negative 5. That's going to be multiplied by 1.2 times 10 to the power of negative 2. And that's going to be divided by, let's work out what I need to do here. It's going to be 4.5 times 10 to the power of negative 5 times by, 2.2 times 10 to the power of negative 2. And that's going to be squared as well. And that's going to be 4.84 times 10 to the power of negative 4. So therefore, I'm just going through the motions to try and get a correct answer because trying to put this all into your calculator at once is going to be relatively challenging. So what that allows me to do is then just type all these out now. So it's going to be bracket, I'm going to put brackets around these and brackets around these in my calculator. 8.836 times 10 to the power of negative 5. That's going to be times by 1.2 times 10 to the power of negative 2. Now I've got all that in a bracket. I'm going to divide that by whatever's in this bracket. 4.5 times 10 to the power of negative 5 times 4.84 times 10 to the power of negative 4. And then I get my answer, which is 48.68, and that is my answer for my K value. So Kc equals this answer. That's how you find K if you know your equilibrium concentrations. All you need to do is first of all write out your expression, substitute the values in. The challenge is going to be random numbers here, but you just work through it consistently and carefully and to the best of your ability with your calculator.